This is chapter 9, question 36. Write the equation of an exponential function of the form y equals ab to the x power passing through these two given points. So this is not shifted up or down. It doesn't have a plus c. So the asymptote is the positive x-axis, the line y equals 0. And we've got a couple points here, and I think probably what I want to do is I want to organize this in a couple different ways. Let's consider a very small table of values in which we have some x's and y's. We do not know our 0th term. We don't know the first term, but we do know term 2 is the number 3. We don't know the 3rd term. We don't know the 4th term. We do know the 5th term is the number 1/9. So if I want to move from 3 to 4, right, for a situation like this where this is exponential, this is not linear, the question is, what am I multiplying by as I jump 1? That's from 2 to 3. This is from 3 to 4. And this is 4 to 5. So I'm multiplying by this multiplier b 3 times. So what is that value? That's going to be the first thing we want to find. And we know from this table of values that if I start at the value of 3 and I multiply by the number b 1, 2, 3 times, in other words, b to the 3rd power, I get the number 1/9. So if we solve this, I think let's go ahead and multiply both sides by 1/3. I can divide by 3 also, but multiplying it by 1/3 puts this number in the denominator over here quickly. They're equivalent to each other, but I see it more clearly here. On the left-hand side, we're left with just b to the 3rd power. On the right-hand side, this is 1 in my numerator and 27 in the denominator. So we could either take the 3rd root of both sides, or I'm sorry, the cube root of both sides, or we could raise both sides to the 1/3 power. Let's do that. Let's raise each side to the 1/3 power. And the reason why I selected a 3rd is I've noticed that inside here I'm cubing this value b. And I know that if I raise a power to a power, right, I'm going to use multiplication to simplify that. Well, if I've got b to the 3rd and I raise that to the 1/3, that becomes b to the 1st power. So all of a sudden, this thing is no longer b to the 3rd, right? B to the 3rd to the 1/3 is just plain old b. And on the other side, we've got 1/27th, and this is being raised to the 1/3 power. So if I evaluate that, I know we've seen this enough that we know what this is. It's 1/3. But if it was a value we weren't quite sure about, we could use one of our calculators to do that. So if I turn this on, I'll go, I will look at the fraction 1/27th. There we go. 1/27th, and I'm going to raise that to the power of 1 divided by 3. And this calculator is making it very clear that this is raised to the 1/3 power. You want to be careful. If you do to the 1 and then divide by 3 on some of the other TIs, it might make that you're raising something to the 1st power and then you're dividing that result by 3. If you're not sure what your calculator is doing, it's always helpful to just go ahead and throw an extra set of parentheses around it. So now I know without a doubt this is 1/27th to the 1/3 power. And when I do that, I can see this, right? And if I'm not sure still what that is, I can always hit math and kick that into a fraction. It's like, okay, that's 1/3. So the value b is 1/3. And now we need to figure out what our 0th term is. Well, if I'm multiplying by b, which is to move forward, I can divide by b twice, right? Once to get the 1st term, and then once again to get the 0th term. So if I take this 27, and divide by 1/3, it's going to give me 81. And if I, not 27. The second term is 3. If I take 3 and I divide by 1/3, that will give me the number 9. And then if I take the number 9 and I divide that by 1/3, up here's 1/3, that will give me the number 27. So my 0th term is the number 27. Let me put this up here in a different color, 27. So now we have the two things that we need. We have our 0th term, A, and we have our multiplier, B. So I can now write this as, as y equals A, 27, times 1/3 raised to the xth power. And you've seen me check these a lot. If I throw in x right now into that, if I put in 2, that's going to be 27 times 1/9, which is 3. And if I put in a 5, don't know what that is. Well, 5, a third, 9th. Let's see, 3, a 9th, 27th, 81st. Yeah, you know what, let me check that one. Just being overly cautious here. 27 times, here's the 1/3. I'm going to raise that to the 5th power, and it should gives me that, which is 1/9, right? Math, enter. Yeah. All right. Another thing that's come up as a topic towards the end of chapter 8 was they talked about standard form. And if I wanted to write this in the standard form for an exponential function, it's a simple switch, right? My first term over here is the number 9. And if I want to write this in standard form, I just write y equals 9 times 1/3. The multiplier is the same. But then instead of raising this to the x power, I raise it to the x minus 1 power. And both of these will produce exactly the same outputs if I give it an x. And the second one is, the textbook referred to this as standard form for an exponential function. And the big difference there is that instead of starting with the 0th term, 27, we start with the first term. And instead of writing x, we write x minus 1 as our power. Okay, that's it.